TSRM-Üreme Sağlığı ve İnfertilite Derneği webinar programlarını sunmak isteriz. Bu akşam yardımlı üreme teknolojilerinde oosit ve sperm aktivasyonunda güncel durum ve gelecek konulu webinarımızı Avusturya Kepler Üniversitesi'nden Dr. Thomas Ebner İngilizce olarak sunacaktır. 29 Nisan Çarşamba 21'de SARS-CoV-2 pandemisi ve infertilite yönetimi konu başlığını Dr. Bülent Urman'dan dinleyeceğiz. 7 Mayıs Perşembe saat 14'te ise üreme endokrinoloğu gözünden AMH konusunu Dr. Hakan Yaralı sunacak. TSRM Başkanı Dr. Ahmet Zeki Işık, luteal faz yönetimi güncel yaklaşım konusunda bir sunum gerçekleştirecek. 20 Mayıs Çarşamba saat 21'de Amerika Boston IVF'den Dr. Deniz Sakkas, bizlere invaziv olmayan embriyo seçimi biyopsinin yerini alacak mı konusunu İngilizce olarak sunacaklar. 27 Mayıs Çarşamba saat 21'de endometriozis ve infertilite, ART mi cerrahi mi konusunu Dr. Erbil Doğan'dan dinleyip sorularımızı iletebileceğiz. 3 Haziran Çarşamba saat 21'de Dr. Berfu Demir bize ART'de frizol doğru mu konusunu sunacak. 10 Haziran Çarşamba saat 21 adenomiyozis ve infertilite Dr. Cem Atabekoğlu tarafından sunulacak. 17 Haziran Çarşamba saat 21'de ise overyan stimülasyonda progrestinler konusunu Dr. Esra Bulgan Kılıçdağ'dan dinleyeceğiz. ART'de tartışmalı girişimler, PRP, kök hücre ve ROSI konusunu Dr. Berrin Avcı sunacak. Sonrasında webinarlarımız devam edecektir.
Herkese merhabalar. Hepinizin malum olduğu üzere hem dünyada hem de ülkemizde SARS-CoV-2 enfeksiyonuyla önemli bir mücadele halinde insanlık. Acaba bu dönemde fertilitesini korumak isteyen, gebe kalabilirliğini korumak isteyen hastalar nasıl davranmalıdır? Aslında bu soruya geçmeden önce standart bir IVF hastası nelere dikkat etmelidir? Bundan bahsetmek lazım. ESHRE ve ASRM, yani Amerika'nın ve Avrupa'nın en büyük iki fertilite cemiyeti Nisan ayında önemli uyarılarda bulundu. Bu uyarılar hem doktorlara hem de hastalara yönelikti. Ne diyordu bu uyarılarda? Bu uyarılarda acil olmayan durumlarda hastanın tedavisinin takip eden aylara ertelenmesi. Tabii ki takip eden aylar için bir tarih vermek mümkün değil. Çünkü bunun için ancak pandeminin kontrol altında olması lazım. Dolayısıyla bu döneme kadar mutlaka bu hastalarda tedavinin ertelenmesi önerdi. Bunun için birkaç gerekçe var. Bunlardan bir tanesi hepinizin bildiği üzere IVF tedavisine gelmek isteyen hasta ulaşım sırasında enfeksiyonu kapabilir. Ulaştığı hastanede enfeksiyonu kapabilir ve ülkemiz genelinde de il dışından gelen hastaların tüp bebek merkezine ulaşmasında bir problem olabilir. İkinci olarak yumurta toplama tedavisi önemli oranda genel sızı altında yapılmaktadır ve dolayısıyla bu dönemde eğer asemptomatik bir hasta var ise COVID-2 enfeksiyonu olan, bu hasta hem enfeksiyonu etrafındaki sağlık personeline yayabilir hem de kendisi anestezi aldıktan sonra semptomatik hale gelip zatürre ile sonuçlanan ciddi komplikasyonlarla yüz yüze kalabilir. Üçüncü bir sebep, hastanın gebe kalması durumunda her ne kadar elimizdeki sınırlı bir bilgi COVID-2 enfeksiyonun çocuklarda henüz önemli bir yan etkisi olmadığını gösterse de ilk 3 ayında SARS-2 enfeksiyonu kapmış bir insan gebelik şu anda mevcut değildir. Dolayısıyla uzun dönemde ne tip yan etkiler getirebileceğini bilmiyoruz erken dönemde COVID-2 enfeksiyonu kapılırsa. Dördüncü olarak da hasta eğer COVID-2 enfeksiyonu kaparsa bazı viral enfeksiyonların gebelikte daha kötü seyredebileceğini biliyoruz. Bunun dışında kullanabileceğimiz antiviral ajanlarında yine uzun dönem o hastalar ve bebekler üzerindeki etkisinden de emin değiliz. Dolayısıyla tüm bu sebeplerden dolayı acil olmayan tüp bebek uygulamalarının hem ESHRE hem ASRM, yani Avrupa'nın ve Amerika'nın en büyük iki cemiyeti ertelenmesini, pandeminin kontrol edildikten sonra bu hastaların tedavi altına girmesi önermiştir. Standart IVF tedavisi dışında fertilitesini korumak isteyen hastalarda nasıl davranılmalıdır? Sorumuza tekrar dönersek. Bu kapsamda yine az önce anlattığımız prensipleri akılda tutmak lazım. Bu hastaları iki kategoriye ayırmak lazım. Bunlardan bir tanesi kemoterapi, radyoterapi, yumurtalık ve spermlere zarar verecek ilaç alacak hastalar. İkinci grupta yumurtalık rezervi az olup takip eden aylarda daha da azalmasından kaygılanan hastalar. Birinci gruptan bahsedersek, eğer bu hastalarımızın kemoterapilerini ve radyoterapilerini erteleme şansları yoksa onkologlarıyla konuştuktan zaman sonraki, ki çoğu zaman da yoktur, o zaman bu hastaların biraz önce bahsettiğim riskleri de göz önünde bulunduraraktan tüp bebek merkezine başvurmaları ve bu tedavilerini ivedilikle alacakları kemoterapiden ve radyoterapiden önce tamamlamaları gerekmektedir. Ancak yumurtalık rezervi az olan hastaların durumu biraz farklılık göstermektedir. Bu hastaların ileriki dönemlerinde yumurtalık rezervinin daha da azalacağı endişesi söz konusu ise o zaman doktorlarıyla konuştuktan sonra bu tedavilerin en azından hastalığın daha çok kontrol edebileceği düşünülen Temmuz aylarına, Ağustos aylarına ertelenmesi daha uygun olabilir. Ancak bu konuda yine hem ASTRM'nin hem eşlerin hem de TSRM gibi ulusal derneklerin ve tabii ki Sağlık Bakanlığı'nın bu konuda yapacağı uyarılar mutlaka takip edilmeli ve güncel olarak da bunlar doktorlardan öğrenilmelidir. Hepinize sağlıklı ve mutlu günler dilerim.
Herkese merhaba. İyi akşamlar diliyorum. Sesim geliyordur inşallah öncelikle. Sağlıklı ve huzurlu günler, geceler dileğiyle bugünkü webinarımıza başlayacağız. Saygıdeğer hocalarıma, öncelikle katılımcılara, meslektaşlarıma çok teşekkür ediyorum. Vakitlerini ayırıp birlikte bu akşam beraber olacağımız için. Üreme Sağlığı ve İnfertilite Derneği ve Klinik Embriyoloji Derneği'nin ortak bir projesi bu çalışmamız. Çok da heyecanlıyım. Heyecanıma maruz görün lütfen. Bunu sunuyor olmak gerçekten çok büyük bir mutluluk. İnşallah birlikte çok güzel projelere de tekrar imza atarız. Ben başta dernek başkanı Ahmet Zeki Işık hocam olmak üzere tüm yönetim kurulu üyelerine, derneğimiz yönetim kurulu ve üyeler olarak çok teşekkür ediyorum. Öncelikle bu imkanı sağladıkları için bizlere de. Bu akşamki konuğumuz aslında çoğumuzun uzun yıllardır tanıdığı üreme sağlığı alanında ve klinik embriyoloji alanında uzman olan Dr. Thomas Ebner. Aslında onu tanıtmaya da çok fazla ihtiyaç yok ama ben yine kısa bir biyografi tanıtım yapacağım. Öncelikle bugünkü Thomas'la birlikte de derleyeceğimiz, tartışacağımız konu yardımcı üreme tekniklerinde yapay gamet aktivasyon uygulamalarının dünü, bugünü ve geleceği. Hepimiz için yıllardır önemli konu. Zorlandığımız vakalarda, çok zor vakalarda zaman zaman başvurduğumuz konular. Bu işin gerçekten teorinden pratiğine böyle bir yolculuk yapacağız bu akşam inşallah. Eminim çok da sorularınız olacaktır. Modere etmekten de mutluluk duyacağım. Dr. Thomas Ebner 1992 yılında Salzburg Üniversitesi'nden onur derecesiyle mezun oldu. Sonrasında doktora sonrası çalışmalarını Salzburg ve Graz Üniversitelerinde devam etti. Öğretim üyesi olarak çalıştı. Halen Kepler Üniversitesi Tüp Bebek Merkezi'nde uzman deneyimli klinik embriyolog olarak, laboratuvar sorumlusu olarak görev yapıyor. 150'nin üzerinde yayını ve kitap bölümü bulunuyor. Özel ilgi alanları bizler biliyoruz zaten bunu ama tekrar hatırlatmakta fayda var. Time-lapse embriyo kültürü, görüntülemesi, girişimsel olmayan embriyo skorlama süreçleri, androloji, vitrifikasyon ve kültür medyumları. Dr. Thomas Ebner aslında aynı zamanda Alfa Üreme Sağlığı Araştırmacıları Derneği'nin eski yönetim kurulu üyesi ve derneğimizin yani Klinik Embriyoloji Derneği'nin onursal üyesi. Bizden biri aslında Thomas. Onu da söylemek isterim. Özellikle çok kendisini seviyoruz ve takdir ediyoruz. Halen Avusturya Embriyoloji Forumu Başkanı ve EŞRE Yönetim Kurulu üyesi olarak görev yapıyor. Ve bu kısa tanıtımdan sonra ben mikrofonu da Thomas'a vermek istiyorum. Dr. Thomas, can you hear me? Hello?
Yes, I can. Hello, everyone.
Excellent. Hi. Hi, Thomas. The stage is yours.
So thank you very much for the kind introduction. At least I guess you have introduced me. I didn't understand the word, but I'm pretty sure you did because you promised to do so.
I tried my best, yes.
Thank you. So I'd like to take the opportunity to thank also the Turkish Society for Reproductive Medicine for inviting me to be part of this series of webinars, which I really consider to be a great idea. And you really anticipated the whole thing. You started the webinars, the organization way before the COVID-19 virus spread. So this is the only chance nowadays to have meetings. And to be honest, it's my 6th or 7th meeting in the last couple of weeks. But I see it's 152 participants, so this is the largest meeting. So I will do my best to be focused on the topic I was given, which is more or less to make it easier, the artificial activation of sperms and oocytes and how to use it in the lab. Before I start, I'd like to declare my conflict of interests. Because I was involved in the launching of two products, one ionophore and one theophylline product, which are commercially available. And although I do not have a financial interest, you should know that I did presentations for this company, for the German company. I did workshops in my lab, and I got ionophore for free for some of our studies. So no one knows better than we as embryologists that it takes two gametes to make a very good zygote and to make an optimal embryo, the best quality blastocyst, and last but not least, a healthy live birth, a singleton live birth. And if both gametes are of best quality, we won't have problems. But we do face in reality often fertilization problems, embryo quality problems, blastocyst formation problems, and failure in pregnancy or implantation. So there is something for us in the lab to do, and this presentation will deal with that. So if we look on the nomenclature of the WH 2010, and we are speaking about sperms, then whatever has to do with motility is now highlighted, meaning that if you talk about asteninoteratozoospermia, azoospermia, cryptozoospermia, necrozoospermia, oligoasteninozoospermia, and oligoasteninoteratozoospermia, all those indications definitely have an impaired motility in the sperm, at least of some of them. And this is in principle no problem because we have ICSI, we can deal with that. But if it comes to the worst, we have to do something. And before I'd like to start with artificial activation of sperm motility. I'd like to talk a little bit on the basics, meaning what is about the motility pre and post ejaculation. So we know, although we have motile sperms in TSRM material, but in principle in the testes, spermatozoa are virtually immotile. And the same is true for the epididymis. The motility there is reduced due to very high viscosity in the epididymis and also to the very low acidic pH. Because this pH inhibits the hydrolysis of ATP and as a consequence the energy production that we need to achieve full motility, or the sperm needs to achieve full motility. And then after ejaculation, when the spermatozoa are more or less mixed with the seminal plasma, then the cytoplasm becomes alkalized. So it goes towards 7 and more, and then the sperm starting to become motile. However, at the very beginning, just after ejaculation, the sperm show a persistent reduced motility since some proteins from the seminal vesicles form a gel matrix that encases more or less the ejaculated spermatozoa. So, and this prevents premature capacitation, because that what we have to keep in mind would be a problem. If a sperm is capacitated right after ejaculation, it could never fertilize an oocyte once it's in the vagina and in the tubes of our wives. So to finally achieve the fertilization potential, the sperms have to complete two major changes: to activate full motility and capacitation. And of course, acrosome reaction, but this is already a little bit later. Since the mode of activation in the sperms happens independently of the composition and the viscosity of the surrounding milieu, for example, it works in culture media, in herpes buffer, this means that the activator of motility has to be simple and omnipresent, so you can find it everywhere. And we already talked about the internal pH, but also calcium. They are important for the maintenance, but not for the primary activation of motility. So once sperms are motile, pH, internal, and calcium concentration becomes more important. But for the start of the activation, it's rather the cyclic adenosine monophosphate camp. It activates the proteinase Ka, which in turn causes phosphorylation. We'll come to it back in a minute, because then we talk about artificial activation of sperms. So this is the normal route, I would say. So this small molecule, CAMP, definitely is a major player in the start of the activation of motility. Also, it's supported by hydrogen carbonate, which makes the pH, internal pH, more alkaline and increases an enzyme called anylyl cyclase, which is important for transforming ATP to cyclic AMP. And similarly, exogenous and endogenous ROS regulate CAMP as well. So small molecules that are of importance. The second process we were talking about is the capacitation. And capacitation, more or less per definition, means the entire set of biochemical processes that allow the sperm to get its complete fertilization potential. And as a first step, usually cholesterol and other membrane proteins are removed from the membrane by means of albumin, mostly, I would say. This is supported by reactive oxygen species, which oxidize cholesterol, which in turn facilitates its transfer to albumin. So once those membrane proteins are removed, then the membrane is more fluid. This means it's more sensitized to chemoattractants or progesterone, as an example, and also for the permeability for calcium. So the membrane changes because the inhibiting proteins are gone. The motility is hyperactivated during capacitation, and hyperactivation, as you know, is defined by an increase in the angle of the flagellar band, which results in more asymmetric-like or whip-like movements and more powerful swimming force, which is important in the oviduct, for example. And when then capacitated spermatozoa encounter the cumulus oophorus, a further increase in pH internal and calcium concentration results in the acrosome reaction. And this then releases the enzymes from the acrosome, which allows the passage through the corona radiata or the cumulus cells itself. So as we said before, it would not be sufficient to be motile. It has to be maintained through all the fertilization process. So the calcium entry in turn is responsible for all downstream physiological steps such as capacitation, hyperactivation, chemotaxis, acrosome reaction, as was just pointed out before. And there are two ways to work with calcium ions if you are a sperm. So one would be that you use pumps, active pumps, to bring in and out calcium, which would be very slow way to react to physiological conditions that change all the time, from the, I would say, ejaculate to the vagina to the fallopian tube. Wherever the sperm gets, it changes the milieu. So it has to be a very fast answer, and the fastest answer definitely is a selective ion channel. So there is obviously one ion channel in the sperm, and this is the CAT-SPER, the cationic sperm channel. And you see that the concentration at rest, I would say, without activation, then there is the proton gradient is 1 to 4, meaning you have a lot of protons within the cytoplasm of the sperm, meaning it's acidic or non-motile. On the other hand, there is a 20,000 to 1 ratio in terms of calcium. So a lot of calcium is outside and a low level of calcium is inside. And both the low calcium in the cell and the high proton rate in the cell keeps the sperm rather immotile. And this changes then once calcium comes in. So the regulation of the calcium balance is via pH. So there is sort of a pH sensor in this CAT-SPER channel, which realizes that there is an increase, for example, let's say from 6 to 7 in pH, and this causes a 7-fold increase in internal calcium. So all of a sudden calcium comes through this channel, through this specialized calcium channel, and increases within the cell. And in contrast, you have to get rid of all the protons. And this is done by specific channels called HV1. They are very specific for a human, so they're not known in the mouse. HV1 is a proton channel that gets rid of all those protons. And protons within the sperm are produced either actively, once calcium gets in, out, you get protons in. The other one is in the metabolism of ATP degradation. You get protons, and also in glycolysis. So there is an enrichment in protons which would bring the pH down. To avoid this, they are actively transported out of the cell. And so calcium is the major player. And the Cat-Sperm channel is a very interesting thing, because here in this paper it is shown that is a very variable expression of Cat-Sperm in the ejaculate. So you have sperms with Cat-Sperm channels that are functional and others which are not. And if you process your sperm, what you do every day in your lab, doing a swim up or a density gradient or maturation chambers, then you will see that a processed sperm gives you a higher rate on Cat-Sperm positive gametes, meaning the better you process the ejaculate, the better quality is the sperm you have in terms of Cat-Sperm positivity. And it has always to do with astenospermia. So if you have more sperms without functional Cat-Sperm channels, then definitely you have low sperms. And the same is here, let me say bottom right. You see, you add progesterone and then you get a reaction. You get calcium coming. And this means in the swim up, you have a better quality or a better response in terms of calcium as compared, for example, to pure sperm gradient, to a single pure sperm gradient. And very interesting, I think, is this paper. Okay, this one is gone, but I will let you know. There is one case report has been published in 2018, one patient being null for this Cat-Sperm. So he has a deletion in the chromosome 18, which is one of the 7 proteins forming the Cat-Sperm channel. And this guy was absolutely infertile, could not fertilize one single oocyte, just because of a small deletion in the Cat-Sperm protein. So this is definitely of interest, I would say, and would be one chance, to act on. So what can we do now to artificially activate sperms in the lab? So there are a couple of methods available, which are not going to talk into detail, but one is heat-induced activation. So if you warm your sperms, I found a study up to 40 degrees for a short period of time, it would activate the sperms. So I would not do that, and this is a very old method. Alternatively, you could apply more physiological stimuli, such as follicular fluid or cumulus cells, to mimic the real situation in vivo. But most of us would choose a pharmacological approach, which is usually done in the labs around the world. And now I come back to that I mentioned before. I'd like to show you the normal way how it would act. So there's a hormone, let me use the arrow, a hormone or any other molecule that comes from outside the cell and docks to the G protein coupled receptor. And this then causes a reaction. So the G protein is released from inside and it acts or it activates adenylyl cyclase. This is the enzyme that converts ATP to cyclic AMP. So this is the molecule we said, which is the most important molecule in terms of sperm motility. And this then activates protein kinase A, and this in turn then goes directly to phosphorylate tyrosine, for example, at the dynein in the axonema, meaning that it causes motility in the sperm. So it's adenylyl cyclase, cyclic AMP, protein kinase A, and then dynein. And if you now, or we have in lab a problem, with the motility. So what could we do in pharmacological thinking? One thing would be to activate adenylyl cyclase. So if you activate it, you have more output of this enzyme, then you have more cyclic adenosine monophosphate. Phospholene, for example, would be such a key player, I would say. Another opportunity would be to inhibit the protein kinase A, because if it's not using cyclic adenosine monophosphate, it will stay within the cell. But the most important pharmacological approach is dealing with phosphodiesterase inhibitors, because phosphodiesterase, as you see here, is the enzyme that degrades cyclic adenosine monophosphate within the cell. And if you inhibit this one, this will be stable or even go up. So this is the principal path we should use. And there are a couple of phosphodiesterase inhibitors available. So this is a unique intracellular hydrolase of this cyclic adenosine monophosphate. There are 11 PDE families which can either be inhibited selectively or more general. This is what we do. We try with pentoxifylline, with theophylline, with coffeine, with all dimethylxanthines that we use in the lab. We try to inhibit all those PDE families, so it's not very special. Whereas the PDE5, for example, is sildenafil, Viagra, is very specific and very selective in inhibiting. Methylxanthines I already mentioned. This is a sort of modified purines, and that's exactly mirroring adenine and guanine, which are also purines. So it's not only that they inhibit those enzymes, sondern also GMP, for example. So it's very easy. It's not very specialized, and it inhibits more or less everything, to say it very easily. This paper is very interesting, because if I would ask you how many PDE inhibitors you know, then yes, it's coffeine, theophylline, pentoxifylline, and then the air gets thin. So these guys used 43 compounds. So 43 different compounds, all of them are known to inhibit phosphodiesterase. And what they did is to get a very poor sperm sample, because they wanted to point out that those substances activate the motility. They mixed a couple of bad quality sperms. They used a density gradient, and then they took the sperms from the 40% Pacol fraction, meaning they had not the motile sperms, they had poorly motile sperms, and that they used with different concentrations of 1, 10, and 100 micromolar of all those 43 compounds. And then they filtered out 6 compounds which performed best, and these 6 compounds then had a further analysis in a more biological way, and I'll come to it in a minute. And this is what they got, for example, such a dose concentration curve. And for this compound number 26, the optimal concentration would be 50 to 100 micromolar. And that's actually what they found out for almost all. So they used for all the testing 30 minutes, 100 micromolar of those 6 different compounds. In the first phase of their trial, they analyzed all 43 compounds, of course, and this is the baseline, so no effect at all. And the green line would distinguish between very strong motivators, I would say, or very poor or intermediate responders to those compounds. And you see 1, 2, 3, 4, 5, 6 were above the line of 60. 100% would mean double motility than they had with the negative control, which was DMSO in this case. So 100% would be double the motility, 60% is the threshold. And then they also found differences in the total motility for these 6 compounds and in the progressive motility. The positive control is IBNX, which is also a methylxanthine. And you see those sperms that were poor in terms of motility at the beginning, after the 30 minutes with these compounds, they were able to penetrate methylcellulose solution, which is very viscous. And this is a measure how strong the motility is. And all of them performed better than the positive control and logically better than the negative control. So what they else found is that 3 hours of incubation in the PDE inhibitors showed no reduced effect. So if you use it once, it's not that you straight have to work with them. You can wait up to 3 hours and the potential of those compounds would not decrease, which is very interesting, I think, because this is not what is recommended for the ready-to-use product if you have this in usage. And now I realized that it's only 20 minutes and not 30 minutes, so sorry for that, 20 minutes in the solutions. And once you washed it, what you would do with IUI or IVF, then you show a stable effect over 6 hours. So no negative effect after 3 hours, stable up to 6 hours for those 6 compounds, which I will name later on. I'd like to stress that theophylline and pentoxifylline actually should not have contact with the oocyte itself. So if you would use it like I do sometimes, if you have an IUI and the sperm sample is very bad in terms of the motility, of course, and you are afraid that you don't get a good number of motile sperms, then I use theophylline and then I wash it out. Actually, theophylline in the ready-to-use concentration is so low, much lower than here, so that it should not do any harm. But nevertheless, in the 80s, 90s of the last century, they made some studies, and there is pathogenetical activation, there is embryo arrest if you incubate theophylline for 24 hours with the oocytes, which you would never do because we only do it, let's say, for 2 minutes or so. Yeah, just to let you know, no contact with the oocyte, please. So, and then they proved that these 6 compounds do not harm to the sperm in terms of apoptosis. So they used phosphatidylserine, which gets from inside the membrane to outside the membrane during apoptosis. And here this is not the case. So you see no difference at all. It's safe. And also the acrosome reaction. So the premature acrosome reaction does not happen with these 6 substances. So whatever they could analyze, they did, and they came out. And now you can guess what is the winner. It's dipyridamole, whatever this is, or ibudilast. So a lot of names you never heard of, except maybe papaverine. At least I never heard of. And I have to stress that neither pentoxifylline nor theophylline were amongst the top 10. And this here does not mean that theophylline is number 33, so this is arbitrary. Arbitrary, theophylline performed better than pentoxifylline, than sildenafil. But the 6 best are these compounds, and they are not available in the lab. Actually, this is medication for some other things. And I would rather warn you to use it. So either pentoxifylline or theophylline, nothing else I would say is usually used. So I'd like to start with pentoxifylline because it was first in market, I would say. And you see 5 millimolar is a very, very high concentration. This was used in the past by this group from Spain, I would say. And you see healthy babies, quite good fertilization. So pentoxifylline worked in sperms with total lack of sperm movement, meaning it's a very extensive astenosospermia, I would say. And another group with a much lower concentration of pentoxifylline used it in testicular biopsies and compared it to hyposmotic swelling test. And I would say, of course, the results with the artificial stimulation with the PDE inhibitor, pentoxifylline, was much better than the hyperosmotic swelling test. So why now theophylline as an alternative? Because it was later in the market, but it has some advantages. For example, its water solubility is lower as compared to PTX, which is pentoxifylline, but it's higher than to caffeine. So it's a little bit difficult to mix it because it's not mixable in watery solutions. You need DMSO, like for the ionophore. But it has a 10-fold half-life period compared to PTX, and therefore it allows for a longer pre-warring period before you use it. So you can equilibrate it without losing its effect. And last but not least, it has been published that higher dosages of pentoxifylline, 1 millimolar or more, decrease blastocyst formation and induce acrosome reaction than when you don't need it. And I found one presentation from the ASRM meeting a couple of years ago. They compared theophylline and pentoxifylline, and it turned out in their study, in the very limited study, that theophylline performed better in terms of miscarriage rate. So pentoxifylline indeed had more miscarriages. So if you use pentoxifylline, please keep an eye on the concentration, that you're not more than 1 millimolar. And for theophylline, the same concentration would be recommended, I would say, for the ready-to-use product. Although I was involved in this compound, I have no idea which concentration is in. So as soon as this ready-to-use thing was available, then we used it for our frozen thawed TC material. And you see, we had better implantation rate here, or I use this here, better implantation rate, better live birth rate. So there was an effect if you use sperms in a frozen thawed TC. And you see why this is the case, because you're much faster. So the time per sperm to look is halved, meaning the longer it takes for all the injection of the oocytes, the more harmful it would be due to the culture conditions, due to ovarian aging, for example. And if you're fast, then you save time, of course, and this helps the oocyte. So the fertilization was not affected. Oh, it was affected, sorry, it was significantly affected. But I wanted to point out that the blastocyst formation was the most astonishing parameter that we had, and also the pregnancies you've seen before. It worked. And then we also used it for some case reports. We had one patient with absolute astenospermia because of a retrograde ejaculation. So we did not know whether this was a harm due to the transport from one clinic to the other, or it was a basic problem. But nevertheless, we used theophylline. We had few, I have to admit, few motile sperms were healthy live births. And right now we have 5 or 6 of those patients. But then we faced the problem with another patient. And this was a patient where theophylline did not work at all. This was a patient with Cartagena syndrome. So this is a cilia dyskinesis plus a situs inversus, meaning cilia are not working, and not even PDE inhibitors can manage that. So we had no chance to get motility. So what we did is we used ionophore, because we were thinking we bring up the calcium from a different direction, I would say. And you see here we split the oocytes. We had 6 oocytes where we did normal ICSI. We had 6 oocytes where we did ICSI with ionophore, but not with theophylline. And the only fertilizations we got was in the group with ionophore, whereas we had no fertilization here. We used a hyperosmotic swelling test, by the way, to identify viable sperm or potentially viable sperms. And these were the 2 embryos. There are 3 embryos, lousy embryos, I would say, vacuolization. Here is a vacuole, nevertheless, twin pregnancy, and still 2 more frozen. So this brings me to the second part of the talk. And this is, of course, artificial oocyte activation, because this was a nice case report leading from one approach to the other, I would say. And this is always my starting slide because it nicely points out that oocyte activation, the one that we want to act on, is one of the 6 major parts of in vivo fertilization, which is cumulus cell penetration, the sperm oocyte binding and penetration via the sonor proteins, the sperm oocyte fusion via Juno and isomo-1, and then, as said, the oocyte activation before the sperm processing takes place, which is the growing, the condensation of the sperm head, and finally the PN formation. So artificial oocyte activation, or oocyte activation itself, is a physiological process entailing 2 processes. One is the release from metaphase 2 arrest, and the other one is the modification of the zona pellucida in order to avoid polyspermy. In short, I'd like to show you, and this is well known because also part of the ASHRAE certification examination, and I also ask it all my students. So there is a soluble sperm-bound protein phospholipase C-sida coming in from the sperm after fusion. And this molecule, PLC-sida, acts on the membrane-bound PIP2, which is phosphatidyl inositol biphosphate, and it cleaves in 2 molecules. One is diacyl glycerol, which further on acts on the zona reaction. And the second molecule coming from PIP2 is inositol 3-phosphate or triphosphate. And this is the major player in terms of oocyte activation, because inositol 3-phosphate or IP3 bounds to its receptors, which are located on the endoplasmatic reticulum. And once this molecule binds to the IP3 receptor 1, it causes calcium efflux from the endoplasmatic reticulum. So this is the best analyzed pathway, I would say, because you see here in this image that there is also another way with NADP or ryanodine. So there are different storages of calcium within the cell, or different way of activating stored calcium from the cell. But we're going to talk about this red highlighted one, IP3, its receptor, and calcium release from the endoplasmatic reticulum. And this calcium is not an efflux, as you might expect. It's definitely in the form of oscillations, meaning over a period of time, you have oscillating calcium efflux. And this is the physiological way how it is. And the sperm-induced oscillations then stimulate the mitochondrial respiration. And this results in ATP production, which is required to maintain the triggered calcium waves. So it somehow triggers itself. And then oscillation cease once the pronuclei are formed. If you have 2 p-end stage, then there is no calcium peak any longer, except right before every single mitotic division you need oxygen, you need also a calcium peak for mitosis. This will be of interest a little bit later on. So this is a very interesting paper from a Belgian colleague, although she's Spanish, but she worked in Ghent. And she nicely showed that you need a stimulus. This is, as we said, phospholipase C-sida. Then you have an on mechanism. This is the one that we just talked about. But what we did not talk about is STIM1 and STIM2 and ORI1. So these are mechanisms or proteins that sense that there is a drop in calcium. If the cell realizes that there is not enough calcium available, then STIM2, and then later on, if it's almost gone, the calcium, STIM1, this is the stromal interaction molecule 1 and 2. They realize there is no calcium, they cluster, they move towards, from the membrane of the endoplasmatic reticulum, towards the membrane of the cell, and opens ORI, which is the channel which allows calcium to get in the cell. And so it refills its internal storages. But this only works for a certain time, not It's not a never-ending story. And then you have effectors or downstream effects, which is always, or the most important one is the calcium calmodulin dependent kinase 2, CAMK2, which on one hand inhibits the receptors here in endoplasmatic reticulum, and on the other hand it degrades EMI2, and this causes the typical zinc spark outside the cell, and this zinc spark is the ultimate signal that there is oocyte activation, I would say. And later on, it works, all of them, on the meiotic promoting factor, which is degraded, and then meiosis goes on. And the last thing I'd like to mention is the off mechanism, because it can happen that at the end of the activation, there is so much calcium in the cell that you have to get rid of the calcium, otherwise it's going to be toxic. And this is done by either these pumps or by natrium calcium exchanges, or calcium goes into the mitochondria. So different ways to get rid of the calcium, and then it's back to baseline. This is more or less everything that one should know. So this potential to be activated, I would say, definitely changes with time during the maturation, meaning that the GV, the prophase 1 oocyte, has a deficit. For example, if you see here, you have a deficit in the calcium response as compared to mature oocytes. But of interest, in vitro maturated eggs, they can't get this potential. So in vivo it works, but not in vitro. The same holds true for the density of the inositol 3-phosphate receptors, which is as low in IVM as in GV stage oocytes, but normal in metaphase 2 oocytes. So to summarize, there is a maturation process where an oocyte has to develop its potential to be activated. And here I'd like to show you this depicted in a better way, I would say, because this is a work from Belgium again. In the GV stage, you have a limited number of receptors being distributed all over the cell, more or less. And then during maturation, the number doubles at least, and it ends up in certain small clusters. So it's not sure what these clusters are used for, but definitely there's a redistribution of those receptors, and after fertilization, again, they are accumulated around the pronuclei. So this is what it should be. There is one type of oocytes where there is too much of calcium, and this is the egg showing the smooth endoplasmic reticulum cluster, which we talked hours about with the Alpha consensus, with the Istanbul consensus, and also with other colleagues. So definitely a positive egg, so an egg showing an endoplasmatic reticulum, has a lower frequency in terms of calcium peaks, but it has a much higher amplitude in the first peak, and it has a much longer duration. So in total, the calcium available is higher in those abnormal eggs, I would say, compared to normal eggs. And this is what the receptors look like. You see clustering right there where the endoplasmatic reticulum cluster is in the microscope. So you see it in light microscope, and you also see it if you go for the receptors. So definitely ionophore treatment is not recommended. It's contradictory. So I would never use it in this type of oocytes. So this is a summarization from Björn Hendricks. So he borrowed this slide to me, showing that the difference between GV and M2, and you see it's an increase in the number of the receptors and the clustering. It's an increase also in the sensitivity and the amount of calcium ions that are stored. There's a reorganization in the cytoskeleton, and of course also in the protein synthesis. And since this is so very complicated, I would say, it's quite obvious that whatever you do in the lab in vitro maturation we already talked about, but also cryopreservation, oocyte aging. If you wait 3, 4, 5, 6 hours for ICSI right after denudation, or let's say after oocyte collection, then definitely the calcium answer will be different. So whatever we do in the lab, we're going to change that. And we just have to be sure that we're on the safe side. So let's talk 2 or 3 or 4 slides on the diagnosis of oocyte activation problems. So in order to accurately inform the patient concerning the potential consequences of the offspring of the baby or of the treatment, and to provide a tailored treatment, you should know if the problem comes from the sperm or from the egg. Because for us it's easy. We use, for example, ionophore. Ionophore, and we don't care about if it's a problem with the PLC zeta, which would be a sperm-related problem, or if the problem comes from the endoplasmatic reticulum, from the receptors, because this would be an oocyte problem. Whatever is the reason of our problem, we use any artificial activation method, and we can pass it if we're lucky. So in principle, I should tell you that you have to go for the diagnosis, for the proper diagnosis. And how can you do that? This is what the Belgian colleagues in Ghent do. So when I have no success with ionophore, I send the sperm or the patient to Ghent, and they do the analysis. They do immunostaining, they do the genetic screening of the patient. And last but not least, they do an heterologous ICSI model, mouse oocyte activating test. So they bring in sperms from the patient in mouse oocytes, and then they look how many of those oocytes they can activate. And you see there is a MOAT group 1 with almost no activation, from 0 to 20%. Then there's the perfect group from 85 to 100%. And there is an intermediate group, which does activate mouse oocytes, but not as they should. So, and the first statement was that the first group, MOAT group 1, is the one with the male problem, where the sperm has a problem, because the patient's sperm cannot activate, and they can compare it with a fertile donor sperm that they use in parallel. So definitely this was their first comment, but then they found out, or they concluded, that actually human PLC zeta is much more potential than mouse PLC zeta. And they think maybe the MOAT is not sensitive enough to detect the real deficiencies. So what they then did, they measured the calcium. This is called MOCA. MOCA means mouse oocyte calcium analysis. And all of a sudden they realized in the group, in the intermediate group, which was more than 20 to 85% activation in mice, which was formerly or previously normal, is now a male problem. Because you see here only few spikes. So the MOCA is much more sensitive than the MOAT, and it gives better results. And they published a paper and showed that if you have 9 peaks or more than 9 peaks, it's normal. If you have less than 9 calcium peaks in the MOCA analysis, it's a sperm problem. That's what they published. And the optimal would be the HOCA, which is the human oocyte calcium analysis. And that's what they currently do. So they have donated oocyte for research, and they use it. The only problem is they do in vitro maturation, and they use also oocytes with smooth endoplasmic reticulum clusters. So they have second quality oocytes for testing. But nevertheless, this is the way they do it. So, and the last part of the talk is how we do artificial oocyte activation in the lab. And I'm not going to talk about the modified ICSI techniques, which aim for invasively depleting the storages, the calcium storages within the cell by doing activated ICSI or invasive ICSI. You open the endoplasmatic reticulum, within the cells, and you also, with the ICSI, with the penetration of the needle, you bring in calcium from outside the medium as well. Another possibility would be electrical activation, and Badaji is one of your colleagues. They used electrical activation to create membrane pores, and then the calcium could get into a cell. They were quite successful, but it needs a special gadgets, I would say. So most of us would go for chemical activation. And chemical activation you can do with a lot of compounds. So strontium is similar like calcium, so strontium chloride is a similar molecule, so it works also with strontium. But as pointed out here, calcium ionophores are the one we should go for, we usually go for, because some of those compounds, they produce more or less physiological oscillations, others do not. But the problem is they are less effective, limited to some species, and they may cause meiotic spindle disruption. So at the end, we all go for calcium ionophore, or most of us. And there you have two products available. One is ionomycin, and the other one is calcimycin, also known as A23187. And the problem with all the papers, because this is a very nice review, I really can recommend you to read that. The problem is that whichever paper you read, one have single use, twofold use, one use ionomycin, the others calcimycin. In terms of timing and concentration, you see concentration, timing, completely different. So there's no standardized protocol to do artificial oocyte activation. But all these methods worked. This is the good thing. But the problem is you can't compare all those studies. So once the ready-to-use ionophore was available, Markus Montag from Germany, he was also involved in launching this product. So we did a prospective study with 100 patients in Germany and Austria. And you see, we used patients with no fertilization in the previous cycle or with a reduced fertilization. So what we call fertilization problems. And you see, whichever group we were talking about, we had a benefit in using an ionophore. And we had 34 healthy babies. So it worked, more or less. Another indication would be severe male factor, because as a byproduct of this study, because we had to get rid of all TZ patients, we published here another paper using a ready-to-use ionophore in TZ patients. And you see, it was so good in fertilization rate, also in isospermic patient, also in cryptospermic patient. It was better in blastocyst formation, implantation rate, you name it, and it was better with the ionophore. And this actually led to the fact that we do every single TZ patient with ionophore, which is more or less crazy, because it should not be underestimated that it's not physiological at all, because it only causes one single peak and no oscillations. So to be honest, if it's a first cycle and he had a vasectomy, we do not do ionophore. But for all other cases where we have bad quality sperms from a TZ material, we use ionophore. And I think we do quite good. So why do ionophores work? This is very interesting because it's one single peak, it's not physiological. And we tried to summarize literature in this commentary in RBM Online. And we found in the literature that the downstream calcium calmodulin dependent kinase activity, it raises and falls with the initial calcium transient. So the very first calcium peak is the most important one. And since calcimycin and ionomycin create one peak, it's enough. Another thing is that once activated, there is something like autophosphorylation. So even in the absence of calcium, ChemK2 may be active. And last but not least, if you have a fewer number of peaks, then you can compensate for it by having a high amplitude or a longer duration. So the area under the curve gives you the calcium that is available for for activation. So no matter how you get it, as long as you get it. And to summarize, this slide is that mammalian oocytes are tolerant to perturbations in calcium oscillations pattern as long as the total amount of calcium release is uncompromised and passes a critical threshold. So if you can't pass the threshold by your method, then you won't have fertilization. And the last indication I'd like to show you, because this is something different, I would say, is to use ionophore to increase mitosis. Here you see, this is the location of the pilsicita. It stops at zygote stage, but then at every mitosis you have one calcium peak. And there is a very close correlation between cell division and calcium. In those embryos that had arrested, a Portuguese group did not find any calcium, so there was no calcium embryo arrest. And if you use a calcium chelator, if you artificially chelate calcium, then you can stop mitosis. So we just thought the other way around, meaning if we apply ionophore in patients that had problems in the past with mitosis, then maybe we can succeed. The only problem was when we went to the ethical votum, they did not allow us to use it, for example, on day 1. So we had to use it right after exit, just the way we published it before. So we had 3 groups. It was a multi-center study in Austria. So group 1 was complete developmental arrest. So they had no transfer in the previous cycle because they had no embryo available or no mitotic active embryo after a couple of days. The second group was a complete developmental delay by 24 hours, meaning no blastocyst on day 5 or 4-cell embryo on day 3, for example. And the last group was reduced blastocyst formation. 1 out of 7 was normal, the rest was not. And here you see, this is the control group, the previous cycle. Blastocization, of course, we had no blastocysts. Sorry, I have to use the arrow. No blastocysts in group 1, no blastocysts in group 2 because we had a delay by 24 hours, and few blastocysts in group 3. And this is the cycle with the ionophore, and of course it was better. Not perfect, something around 50%. But again, we had 28 healthy babies in a group that never even had transfer before, or at least not a very promising one. In the same year, a group from Egypt did the same. They used an ionophore to stimulate zygotes that arrested. So they had zygotes that arrested, they did not cleave, they used an ionophore, and then they went on with cleavages and they had a pregnancy, at least one. And I'm not sure if this was a problem of the lab quality in Egypt, because I did not face very often 2PN that do not cleave, that all do not cleave, to be more precisely. But nevertheless, it was very interesting. And last month, and this is the one I hope is here, yeah, it's here. This is very interesting because this group from China, they had 44 hours, no cleavage. So on day 2, they used ionophore. This was just that what we had in mind to do. And you see, they had 1 successful pregnancy. This is quite interesting. On the other hand, it's quite alarming, I would say, because if I see a cell not cleaving for 2 days, for interest, I would treat it with ionophore to see what goes on, but I would never transfer it. But anyway, it obviously worked. So to summarize, when should we at least think of any artificial activation method? So one thing, and this is the most important one, is complete fertilization failure in the previous cycle. But also if you only have less than 30% fertilizations in the previous cycle. Then we also published severe male factor, in particular azoospermia and cryptozoospermia. Then one of your colleagues used it successfully in frozen sperm. So if the quality after thawing is not as good, you can treat it with ionophore after ICSI. And there are also the possibility to use it if you have developmental problems, as I just pointed out before. But if you have indications, there are also counter-indications. And one is, for example, globozoospermia. And in terms of globozoospermia, I have to stress that the ready-to-use product is not as potential as ionomycin. I would not say it's not as potential. It's not potential at all, I would say. That's what I heard from Nikiforakis. So if you have patients of globozoospermia, then you should go for the Ghent model, and they do it differently. The ready-to-use product, you do ICSI, you make an incubation right after ICSI for 15 minutes, and then you wash it, and then you go for the long-term culture. In Ghent, they do the ICSI, and with the ICSI, they inject calcium chloride, small amount of calcium chloride. Then they do ionomycin, 50 minutes, then they make a rest of half an hour, and then do another ionomycin for 15 minutes. So it's a double stimulus, plus injection of calcium chloride, which I am not allowed to do in my country. It's too invasive. Nevertheless, you get better fertilizations, definitely in globospermia. Again, one Turkish colleague found that it's not working in low ovarian response patients, which is, I would say, quite obvious, because the quality, it's more or less the quality of the genetics of the eggs. So I think ionophore or anything else can't rescue genetics. Yeah, and definitely you should not do it in immature eggs and in SER positive eggs. Yes, and last but not least, a few words on the safety of these techniques that we do. And maybe you follow these commentaries in ABIM Online. Jonathan Blurcombe and Jacques Cohen, they pled for more caution. Then the colleagues from Naples, they said, yeah, we do over-treat the patients. And most probably this had something to do with our paper that we published in ABIM Online, because I just mentioned the number of healthy babies, but there was one baby which had an anal atresia, which is a major malformation. And then we had problems to publish the paper, because we had to prove that not the ionophore is responsible for this malformation. So we had to go into literature to all IVF registers to see how often anal atresia we see, how often it is the normal population. And we should not forget that this is a patient group with a very bad prognosis from the very beginning, because they already had a couple of failed cycles before. So last but not least, we started this discussion on the safety. And so I started to collect data. And there is one contra, I would say. This is again from Björn Hendrik's group from Ghent, because he found if you have immature eggs and you leave it in culture, you do maturation, and you use ionomycin in this case again, because he's from Belgium, then you don't get normal spindles. In other words, for in vitro maturation, artificial activation is not the best. But on the other hand, a couple of years later, there was this publication in ABIM Online. They really had an IVM cycle in a patient without activation, which did not work. And then they used it with A23187, 10 micromolar. And you see now they had fertilizations and they had healthy live birth of twins. So this was a case, obviously, with a normal spindle after AOA usage. But you should be aware that there is some discussion going on about that. More interestingly is this paper from Lauriensis group, because the Roman colleagues, they used a 10-fold concentration of ionophore. So we use something like 10 to 15 micromolar, and micromolar, and they used 100 micromolar. And they did not find any influence on the chromosome segregation areas in meiosis 2, meaning so ionophore treatment does not harm meiosis itself, and obviously not the spindle also. This is from Markus Montag, who had a presentation in London. He compared patients with and without ionophore treatment, and he did not find any difference in morphokinetics. This led him to conclude that ionophore at least does not change the mitotic behavior, at least. These are not patients with problems in the past, you should not forget. So the morphokinetics still are the same. And we did something similar and presented it at the Alpha meeting in Reykjavik. This is half of the eggs with ionophore, half of the eggs without ionophore. So we had sibling oocytes and we had the same result than Markus Montag. So the morphokinetics are not changed. It's not the segregation, it's not the spindle. It's not the gene expression, obviously, because using in this case, strontium chloride. Strontium chloride is closer to IVF than ICSI alone, at least in this study, in terms of gene expression. And this is the most recent, I would say, most interesting, not most recent, because this is the outcome of 10-year-old children after assisted oocyte activation. And you should not forget, they do the very invasive method. Nevertheless, no differences in language skills, motor skills, cognition. So whatever we do, it seems to be safe. But as I told you, there are cases where you can't succeed. So you do any type of artificial activation and you end up without fertilization again. And then it makes no use to do it over and over again because it's not working. So what you can do is either to increase the exposure time, meaning going from 50 minutes to 20 or 30 minutes, which can found in the literature. You can switch to twofold exposure. This is what we do. So we use ionophore 15 minutes, half an hour break, 15 minutes again, without injection of calcium chloride. You could also switch two different ionophores, for example, calcimycin, ionomycin. Yeah, then already mentioned the Ghent method, the direct injection plus 2 times ionomycin, or you can use recombinant PLC-SIDA. What we do now, we have first live births, 3 live births with a ready-to-use ionomycin, because based on the paper from Nikiforaki, who found that ionomycin in general is a little bit more, it's better in terms of activation than calcimycin. So we did ask the company, the one I mentioned before, to produce me a ready-to-use ionomycin. And we did have it for test. We went to the ethical votum again, and we used it, I think, in 10 patients that did not succeed with ionophore treatment with the previous version. And then I used the ionomycin, and 3 out of 10 succeeded to live birth. There were 4 pregnancies, 3 went to live birth. So in 6 cases, it did not work at all. The ready-to-use ionomycin, of course, is not available yet because it's a matter of money. So they need the CE certificate. We just have to follow up the children. And maybe if one of you is interested in testing it, please give me not a call, or if you have my number, you can call me, but you can, of course, mail me. And I will, let the company know to provide you with such a ready-to-use ionomycin if you have a problematic patient. Yes, and the ultimate one would be the recombinant PLC-SIDA, because this is what creates physiological oscillation, as you see here. This is a human egg, nice pattern, by simply injecting recombinant human phospholipase C-SIDA. The problem is the concentration is not known. So there was one presentation, I think, in Spain at the Escher meeting, and they tested that a dose curve, and they found the optimal concentration of recombinant PLC-SIDA, but it has never been published as far as I'm aware, and it's not on the market yet. But this is definitely the ultimate goal to use. Yeah, and this is my last but one slide. This is just, and since this is recorded, and I think Nechati will keep the slides, you can, and it's published here, you see in this book that's coming up, this summarizes everything that I've said here. So starting with failed IVF, going to ICSI, you have no fertilization, go to artificial oocyte activation. This is the indication you should use or you can use. These are the techniques that are available. And if you have a fertilization, transfer it. If you don't have it, go for recombinant PLC-SIDA and so on and so forth. And if you don't succeed at all, you have to go either to sperm donation or to oocyte donation. And in this case, you have to know what is the problem. Is it the sperm or is it the oocyte? So this is the summary from the ionophore part. The only important thing to mention is the last sentence. It's experimental. It seems to be safe. If you have no other chance, you can use it, but you have to have informed consent from the patient. At least we do it. Once it's published, I think you don't need the signature of the patient, but nevertheless, I'd rather be on the safe side. So thank you very much for your kind attention. And sorry for it was 1 hour, 10 minutes, a little bit too long, sorry.
Well, Thomas, I'm really moved by it. I mean, I think all the other participants agree with me that, it was a very nice transition from the theoretical aspects to the practical side. So it was very comprehensive, and I'd like to thank you again for giving us the opportunity to listen to your talk. So we have several questions, and fortunately, nearly all of them are in English, so that I don't need to translate from Turkish to English very much. But let's go from the last to the first. Then thanks for the nice presentation. Have you ever tested the oocytes molecular changes, which has no fertilization after calcium ionophore exposure, to understand the pathway of fertilization failure? And what can affect this process?
This is definitely a very good question, and it hurts me because this is exactly what we're not allowed to do in Austria. So there's no way to analyze the egg, no donation of eggs for anything. So this is, all I can do is read literature, look what the Belgian colleagues do and other colleagues around the world, Swan and co-workers, and then try to fit it within my model. It's just trial and error. So there's no way to go into details, unfortunately.
Yeah, and Dr. Ishik also asked one question, which was I was actually thinking about asking you, because in your presentation you mentioned the use of theophylline in IUI, and also you have shown before that calcium ionophore was effective in globozoospermia. But then you said that it's a contraindication for globozoospermia. So I think we have to clear this out.
Yes, this was my fault. I was not very precise. I tried to say that the ready-to-use compound, the one from the German company, this one is not effective in globozoospermia, according to the Greek colleague, Nikiforaki.
You mean the ready-to-use compounds, but not the molecule itself. It's the ready-to-use compound that we're talking about.
If you have a globozoospermia, you have to use ionomycin, and the other one is calcimycin. So ionomycin, yes. Calcimycin, no. Ready to use, no.
Okay. Do you think that any of this methodology or methods are superior to others, like electrical stimulation, calcimycin, ionomycin?
Yeah, my problem is I have no idea how this piezoelectrical activation works. So my problem, my limitation is the equipment that I don't have. For those colleagues that work with it, most probably it's like doing ICSI. It's very easy. I'm sure about it. But my approach is, if it's just a bath, I prefer any type of ionophore because it's CE certificated. And if I have a CE certificated, our national agencies, they say you have to use CE certificated. Although it's only medical device, you should not forget it's only medical device. It's not a, I don't know the other one. So it's a second class CE, I would say. But for most of the countries, including the UK, it's fine.
There are several questions regarding the patient selection. So in one of your slides, you actually listed the cases that are getting benefits of this activation for fertilization failure, like with previous fertilization failures and others. Do you also recommend to use them without indication? So the first 60 cycles.
Yeah.
What's your opinion on this?
I feel like Big Brother is watching me because this is exactly what happens. I'm so ashamed because our clinicians, they come to me and say, we have a patient. They come from a competitor's clinic, 2 failed cycles. Everything was normal. Let's do ionophore without indication at all. So this is definitely something we should be alarmed. So what we do in this case, if the patient wants something, that we do something, and there is a small chance that ionophore can help in terms of mitosis, for example. What I did not say is ionophore never makes the embryo better. The quality of the embryo itself is not better. Plus the cyst formation, yes, but not the fragmentation. Everything is the same. So the thing is, we split the oocytes, and the patient has not to pay. So we do half, and then we see whether the ionophore works or not. But this is mostly in patients with 0% normal sperms.
0% normal sperm.
Complete teratozoospermia.
Okay. How do you perform IVF in your clinic?
Pardon?
How do you perform IVF? I mean, the protocol for IVF.
Just
in vitro
I
fertilization.
don't do IVF. That's why I ask all the time the same.
Okay.
I only have 3% of IVF.
Okay, that was one of the questions. What do you think about round spermatid injection? It's a kind of sperm activation.
Rosie.
It introduces by Tanaka. Rosie, yes.
Finger off. Would never ever do. I would say, if I would do it, I would use ionophore or anything that could help. But in terms of live birth rate, as far as I know, there is not a single live birth. Not from the elongated ones, but from the real round spermatids. Is this correct? At least I'm not aware of one live birth.
Well, there are several papers. I think a couple of months ago, there was a Congress abstract that summarizes all of the previously published articles. So there are very variable numbers of outcome, like in terms of pregnancy and live birth. Yes, I think it's better to discuss it maybe in a separate.
Use it because this would be. Yeah. At least.
Yeah. Another question is: could cleavage arrests be another indication for oocyte activation?
Yeah, this was part of my paper, class 1, group 1 was cleavage.
And you also said that the system or the approach can be used to increase the mitosis. Because in mitosis, you also calcium-dependent activation of each cell cycle. So, I mean, how can it be done? Is it like injecting or putting ionophore in every step before a cleavage, or every day, like you replenish the media?
Well, the problem is that you need one negative cycle to realize that there is a problem. You don't know it once. Well, theoretically you could do it if you have 2 cell embryos on day 3. You could add ionophore. Because then you have viable embryos, but very slow ones. And if you then bring in ionophore, any type of, then you could increase internal calcium, which then is used for the mitosis. But then you are prospective, you are afraid that maybe the embryo will arrest. But theoretically, you should treat half of them, and half of them you don't treat. Like the guy did the last one with the 44 hours no cleavage. He did it, he realized in the same cycle there is no cleavage, and then he rescued it. Which is for me a little bit risky, I would say. But anyway, it worked in his hands.
So if you assume that you have like 10 oocytes, you don't see any morphological defects from the spermatozoa, and you perform your routine ICSI, and the next day you see beautifully fertilized 10 oocytes in your hand, and you feel safe. But the next day you realize that none of them cleaved, so all of them stayed at 2 p.m. on day 2. What do you do? That's my personal question.
I refer you to the Egyptian paper. They used an ionophore. They succeeded.
Okay. So, I mean, you would do the same, right? If you see this kind of case. Or
2 p.m. not clear. 1 or 2 out of 10 maybe, but all 10 of them I don't know why.
I mean, very rarely, but I've seen 2-3 times. I mean, in my last, couple of years, yes. Yeah. Okay. The next question is: what is your advice for tail stump sperm and DAG defect sperm?
This is not similar, but it's something like the Cartagena syndrome. I would also try to do it with ionophore. Theophylline or pentoxifylline won't help. And there's only a little chance that ionophore might help, but better than to do nothing.
And there is one question regarding more like theoretical part of the presentation. What type of receptors affiliated to pathways, that is phospholipase C and DAC adrenergic or cholinergic? Do you have any information?
No, can I read? Where is it?
Yeah, it's the like a third line from the beginning of these questions. Can you see them
No.
from your screen?
But definitely I can't answer the question. So I'm out of my comfort zone, I would say. If it comes to the type of receptor, definitely not my cup of tea.
Okay. There was one question from Sinai. Do we stimulate cat-spur expression by doing gradient or swim up? Or just do we select the sperm with cat sperm plus sperm? Thanks.
The letter, yes. You select them.
Okay. And yeah, there was a question regarding which way, which methodology we should select or maybe go for. Yes, the globosospermia. So I think we nearly answered these questions. Yes. Any other question? I don't know. And you clearly mentioned that seropositive oocytes is a contraindicated to use artificial oocyte activation. So that's important information for all of us, because when we speak about oocyte activation, we normally focus too much on the sperm side. Mm-hmm. We normally don't concentrate on the oocyte morphology itself, but this is a good information for myself as well. And I have a small note regarding MOCA test. That the test that I think the people from Belgium are applying. So do you think that the result of the testing can change from time to time from with the same sample? Do you know any information regarding that the testing result is consistent?
I don't think, personally, I don't think so. I think there will be variation.
You don't think so?
But I think if it's below 20%, it will be below 20% all the time, you know? And since with the MOCA, the first two groups are bad quality sperm, which is up to 85%, any deviation has no consequence, I would say. One time it's 37, one time it's 45. It's still a problem of the sperm, obviously.
Okay, we have a question from Özcan. I think he knows you.
Yes.
One of your students, as I believe. Thanks. Hi, Thomas. Thanks a lot for the nice presentation. Do you have any experience with the combination of two ionophores? Kind regards from Switzerland.
Yeah. I don't have, obviously, I don't have experience. This was based on the suggestion of a Japanese paper, which I can send him if he really needs it.
Okay. Does these procedures, the procedure that you mentioned clearly, trigger parthenogenic division of oocyte? So I believe that if you use a certain concentration or above certain concentration, you can also induce parthenogenic oocyte activation, right?
Well, this was reported for pentoxifylline, not for the ionophore.
Yeah.
It also has only 1% of DMSO, which is known for parthenogenetic activation. So I think above 7% DMSO, it's getting complicated. So not that I have any hint that it would be the case. I can't exclude it, but I don't think so. Not at this concentration.
Okay. Another question, does the activation increase trophoblast division speed? I think it's...
According to the time-lapse morphogenetic analysis we did, it was no difference. But, you know, it stopped with blastocell formation, so I can't tell you.
Okay.
I'm not sure.
So, as a take-home message, for indications, should we concentrate on sperm or egg?
Personally, I would concentrate on the egg.
On the egg. It's a very provocative question from Kerem. Yes. Okay. So I think we answered nearly all the questions. And let me check whether we have another one. Okay. Yes. I think we answered all of them. And Thomas, well, I'd like to again thank for your time and effort and kindness to be with us tonight. I hope that we're going to be seeing each other very often in these coming days. And again, thank you for your time. On behalf of...
Don't forget, ESHRE will be online. So it will be a virtual congress. Every presentation of the ESHRE Congress is recorded in advance. So it's a one-to-one presentation with live discussion. So it's free for ESHRE members. No costs.
Okay. Excellent. Yeah. I think this pandemic is going to change our scientific life totally. So we will see. I think we try our best to get the best of it, let's say.
And otherwise we see in November in Antalya.
Okay, good. Excellent. Again, thank you very much. Thank you so much for coming.
Bye.
Yes.
Bye-bye.
Okay. Bye-bye. Take care.
TSRM-Üreme Sağlığı ve İnfertilite Derneği webinar programlarını sunmak isteriz. Bu akşam yardımla üreme teknolojilerinde oosit ve sperm aktivasyonunda güncel durum ve gelecek konulu webinarımızı Avusturya Kepler Üniversitesi'nden Dr. Thomas Ebner İngilizce olarak sunacaktır. 29 Nisan Çarşamba 21'de SARS-CoV-2 pandemisi ve infertilite yönetimi konu başlığını Dr. Bülent Urman'dan dinleyeceğiz. 7 Mayıs Perşembe saat 14'te ise üreme endokrinoloğu gözünden AMH konusunu Dr. Hakan Yaralı sunacak. TSRM Başkanı Dr. Ahmet Zeki Işık, luteal faz yönetimi güncel yaklaşım konusunda bir sunum gerçekleştirecek. 20 Mayıs Çarşamba saat 21'de Amerika Boston IVF'den Dr. Deniz Sakkas, bizlere invaziv olmayan embriyo seçimi biyopsinin yerini alacak mı konusunu İngilizce olarak sunacaklar. 27 Mayıs Çarşamba saat 21'de endometriozis ve infertilite, ART mi cerrahi mi konusunu Dr. Erbil Doğan'dan dinleyip sorularımızı iletebileceğiz. 3 Haziran Çarşamba saat 21'de Dr. Berfu Demir bize ART'de frizol doğru mu konusunu sunacak. 10 Haziran Çarşamba saat 21, adenomiyozis ve infertilite, Dr. Cem Atabekoğlu tarafından sunulacak. 17 Haziran Çarşamba saat 21'de ise overyan stimülasyonda progrestinler konusunu Dr. Esra Bulgan Kılıçdağ'dan dinleyeceğiz. ART'de tartışmalı girişimler, PRP kök hücre ve ROSI konusunu Dr. Berrin Avcı sunacak. Sonrasında webinarlarımız devam edecektir.
Herkese merhabalar. Hepinizin malum olduğu üzere hem dünyada hem de ülkemizde SARS-CoV-2 enfeksiyonuyla önemli bir mücadele halinde insanlık. Acaba bu dönemde fertilitesini korumak isteyen, gebe kalabilirliğini korumak isteyen hastalar nasıl davranmalıdır? Aslında bu soruya geçmeden önce standart bir IVF hastası nelere dikkat etmelidir? Bundan bahsetmek lazım. ESHRE ve ASRM, yani Amerika'nın ve Avrupa'nın en büyük iki fertilite cemiyeti Nisan ayında önemli uyarılarda bulundu. Bu uyarılar hem doktorlara hem de hastalara yönelikti. Ne diyordu bu uyarılarda? Bu uyarılarda acil olmayan durumlarda hastanın tedavisinin takip eden aylara ertelenmesi. Tabii ki takip eden aylar için bir tarih vermek mümkün değil. Çünkü bunun için ancak pandeminin kontrol altında olması lazım. Dolayısıyla bu döneme kadar mutlaka bu hastalarda tedavinin ertelenmesi önerdi. Bunun için birkaç gerekçe var. Bunlardan bir tanesi hepinizin bildiği üzere IVF tedavisine gelmek isteyen hasta ulaşım sırasında enfeksiyonu kapabilir. Ulaştığı hastanede enfeksiyonu kapabilir ve ülkemiz genelinde de il dışından gelen hastaların tüp bebek merkezine ulaşmasında bir problem olabilir. İkinci olarak yumurta toplama tedavisi önemli oranda genel siz altında yapılmaktadır ve dolayısıyla bu dönemde eğer asemptomatik bir hasta var ise COVID-2 enfeksiyonu olan, bu hasta hem enfeksiyonu etrafındaki sağlık personeline yayabilir hem de kendisi anestezi aldıktan sonra semptomatik hale gelip zatürre ile sonuçlanan ciddi komplikasyonlarla yüz yüze kalabilir. Üçüncü bir sebep, hastanın gebe kalması durumunda her ne kadar elimizdeki sınırlı bir bilgi COVID-2 enfeksiyonu çocuklarda henüz önemli bir yan etkisi olmadığını gösterse de ilk 3 ayında SARS-2 enfeksiyonu kapmış bir insan gebelik şu anda mevcut değildir. Dolayısıyla uzun dönemde ne tip yan etkiler getirebileceğini bilmiyoruz erken dönemde COVID-2 enfeksiyonu kapılırsa. Dördüncü olarak da hasta eğer COVID-2 enfeksiyonu kaparsa bazı viral enfeksiyonların gebelikte daha kötü seyredebileceğini biliyoruz. Bunun dışında kullanabileceğimiz antiviral ajanlarında yine uzun dönem o hastalar ve bebekler üzerindeki etkisinden de emin değiliz. Dolayısıyla tüm bu sebeplerden dolayı acil olmayan tüp bebek uygulamalarının hem eşe hem ASRM yani Avrupa'nın ve Amerika'nın en büyük iki cemiyeti ertelenmesini pandeminin kontrol edildikten sonra bu hastaların tedavi altına girmesi önermiştir. Standart IVF tedavisi dışında fertilitesini korumak isteyen hastalarda nasıl davranılırdır? Sorumuza tekrar dönersek. Bu kapsamda yine az önce anlattığımız prensipleri akılda tutmak lazım. Ve hastaları iki kategoriye ayırmak lazım. Bunlardan bir tanesi kemoterapi, radyoterapi, yumurtalık ve spermlere zarar verecek ilaç alacak hastalar. İkinci grupta yumurtalık rezervi az olup takip eden aylarda daha da azalmasından kaygılanan hastalar. Birinci gruptan bahsedersek, eğer bu hastalarımızın kemoterapilerini ve radyoterapilerini erteleme şansları yoksa onkologlarıyla konuştuktan zaman sonraki, ki çoğu zaman da yoktur, o zaman bu hastaların biraz önce bahsettiğim riskleri de göz önünde bulunduraraktan tüp bebek merkezine başvurmaları ve bu tedavilerini ivedilikle alacakları kemoterapiden ve radyoterapiden önce tamamlamaları gerekmektedir. Ancak yumurtalık rezervi az olan hastaların durumu biraz farklılık göstermektedir. Bu hastaların ileriki dönemlerinde yumurtalık rezervinin daha da azalacağı endişesi söz konusu ise o zaman doktorlarıyla konuştuktan sonra bu tedavilerin en azından hastalığın daha çok kontrol edebileceği düşünülen Temmuz aylarına, Ağustos aylarına ertelenmesi daha uygun olabilir. Ancak bu konuda yine hem ASRM'nin hem eşlerin hem de TSRM gibi ulusal derneklerin ve tabii ki Sağlık Bakanlığı'nın bu konuda yapacağı uyarılar mutlaka takip edilmeli ve güncel olarak da bunlar doktorlardan öğrenilmelidir. Hepinize sağlıklı ve mutlu günler dilerim.